Hi guys, welcome to the Ellen Room. I'm Tony Alden, and today in this episode 9 we are going to talk about penalty transaction on Core Lightning. The question is, when does a penalty transaction happen? It happens when the node L1 with a channel open with a node L2 try to cheat the node L2 by sending a revocated transaction that benefits him, where the balances of the channel benefits him, and when the node L2 catch it on chain and send a penalty transaction to give the fund of the channel back to him. So in this episode we are going to see how we can make the node L1 try to cheat the node L2 with the technique of doing a backup of the database of the node L1 when the balances of the channel benefits him. So this is the game of today. I hope you will enjoy the video, and this is the part, the step, we have 8 steps, and at the end we are going to look at the test channel lesser cheat, which do something kind of similar what we are going to do today, and this is a good occasion to have a look, the first look in the Ellen Room to the test in the Ellen Room in the Lightning repository. If you want another way to do it, we've done that in the previous episode, the episode 8, and you can find the transcript at ellenroom.live. So let's go. We go on in the terminal. We are in the Lightning repository, and as you can see, I've already done some part of the work, that is just to set up Lightning network running on regtest with 2 nodes. So here we use the startup regtest script provided in Lightning repository that we used in all the episode. Here we start LN2, we start 2 Lightning nodes running on regtest. We have 1 wallet on the Bitcoin chain that is named default, and here we have the aliases L1-CLI, L2-CLI, and here we can see the aliases for L1-CLI that run Lightning CLI. So this is what we want, where the base directory is set to temporary L1 regtest, and the last part is this one where we fund the channel between the node L1 and L2 with 1 million sats. So here, this is the first part that we can read at the top, and the second part is going to be the backup of the database. But before we do the backup, we are going to look at the fund in each part of the channel and each wallet, Lightning wallet of each node. So here we want the list fund, and we want the outputs. So here are the outputs. So this is what we have. So this in the wallet L1. Here this is 1 million 1 Bitcoin minus the 1 million satoshis that we used on the fees that we used to open the channel between L1 and L2. Let's do something here on the node. We can look at the channel. There is only 1 channel that we can see here, and the channel for the node is open. We are going to see after with the node L2, and there is the amount in the part of the node L1 is the 1 million satoshi, and the amount here the total amount is 1 million satoshi. So if we do a backup right now of the database, this is the best case, because we are going to send back, when we close the channel, everything to the node L1. This is what we are going to do after, but now just we look output the node L2 has nothing in its wallet, and now we look at the channel and we can see it has the same channel open with the node L2, but the node L2 has nothing in its side. So here we are. So if we close, we can do a mutual close. Everything is going to went perfect, but this is not what we are going to do. We are going to do the backup of the database. We've seen that the directory of the base directory for the node L1 is this one, and we know that the databases and all other information that are not configuration are in that repository. We can do ls-1. So here we have the thing that we can touch, and now we are going to do a backup of this database. So Lightning D, there is another, but it's for a bookkeeper plugin. We call it back. So here we've done the backup. We just keep it to use it after. So let's see if we are going to do the thing in the order to not mess up. So we did the backup of the database of the node L1. Now let's see the node L1 spend some SAT by paying an invoice to the node L2. So here to pay an invoice. Okay, so L2 CLI invoice. So we want an invoice of, let's say, 20,000 SAT. We call it, we give it the label inv. As usual, this is a pizza, and we just want this field of the output. We want the bolt 11. So we have it here. We copy it, and we are going to use it to let the node L1 pay that invoice. So we use the command pay. We pay that invoice. The invoice has been paid, and now what we can do is to look again at list fund of this one. So we can see now that the node L2 has 20,000 SAT in his side, and if we do the same for the node L1, it has 20,000 less here, 20,000 SAT. So we are going right, and now we are going to stop the node L1. We are going to let the node L2 running, because after the node L1 we are going to roll back the database. So we are going to use the backup database to close the channel step by step. Bear with me. So now L1 CLI, we can stop the node. So the node had been stopped. Now we copy the backup of the channel of the database. Yes, so SQLite back. We put it in place of the right one. So now we've done that. We are going to start again the node L1, but we don't want him, because remember that the node L1 want to cheat the node L2. So we don't want him to reconnect with the node L2. So this can be done. We are going to start the node offline, and this can be done here. I have my cheat sheet, so with the option --offline. --daemon is just because we want to start it as a daemon. So we are going to run that command. We go back here. So we are start the node L1 offline. the node L2 is still running. So we do that, and let's just check that we are alive and we are not connected with our peer, which could be only the node L2 on that thing. So dash F is for flatten the result, and we can grep for connected. So for the field connected, and we should have false. So the node L1 has been started again, is not connected with the node L2. Now let's see as we change the database and we roll back to the backup of a previous state, we should have something like list fund, this one, and normally we should have all the fund in our side. So this is what we see on that line. So now this transaction with the other database in the side of the node L2 has been revocated. This state is no longer the true state of our channel. So if we closed now this channel, we are going to try to cheat the node L2. So let's do that, because this is what we want to do. Just say if this is the thing, we are here. So node L1 tries to cheat the node L2 by doing an unilateral close. So L1 do a unilateral close, so we use the command close. We want to close the channel, this one, 103.10, and we want unilateral timeout 1. So after 1 second, as we are not connecting, we are not waiting for a reconnection between the node, and we are closing the channel, which will sign the last commitment transaction and send it to the regtest chain. Here we are, and you can see we'll negotiate once they reconnect, 1 second before unilateral close. So we've done it, timed out, and here we can read we forced the close. So okay, this is fine, but we just send it to the blockchain, but nothing happened in the regtest chain because we are running the regtest chain our service. So we have to mine one block to see the thing happening. Let's see in the side of the node L2. So the node L2 is still connected and is still, we can do that, list fund. And for the node L2, this one is still, now he knows that he is no longer connecting with us, with the node L1, but for him, it still have this 20 Farden sat. If we look at another thing that we can look at is list peers in the field status. So JQ is just for the color right now, and we see in the status as nothing happened so far on the chain, the status is just normal, and it will try to reconnect to the node L2 after some amount of seconds. So now we are going to generate a new block. So Bitcoin CLI, we are on regtest and RPC wallet for the wallet default, and we want a new address to mine a block. And now, so generate address to this one, and we generate one block, and we send it to that generate to address. So we've generated to this address, and now things are interesting. So list peers, we list the peers. So first, let's see the node 1. So this is funny. So the node 1 is here, and in the part of the status that we can read here, he's waiting for 5 more blocks to spend is delay output. So because he did a force close, a unilateral close, he has to wait to spend his part, and this is done by we have this or, so this is here we have it because or to self delay. This is a delay in blocks. He has to wait 6, so he's waiting for those blocks. But the node L2, another story. So this one was looking at the chain, and I've seen that something happens. That means that the funding transaction has been spent unilaterally and not with revocated transaction. So he sent to the regtest chain the penalty transaction. So here the things are happening, and now if we just generate one more block that we can do here, so we send to dev null, this will mine the penalty transaction, and the funds are going to be send all the funds of the channel are going to be for the node L2. So we just see again this. So now it's okay, the penalty transaction happened, just waiting 99 more blocks for forgetting the channel. Okay, so we can do that as we did in the other episode to really forget the channel. Let's see if we did everything. So yes, now watching for the funding transaction. We are here, we are almost done. We are just going to see the outputs in the Lightning wallet of the node 1 and in the Lightning wallet of the node 2 to observe that the node 2 has all the funds of the channel. So list fund, okay, so we have it here. Maybe we want, because we want the output of L2, and here it is. So remember that the node L2 had nothing in its output and in its wallet, and now he has the whole amount of the channel, which was 1 million satoshis minus the fees. And if we look at the node L1 here, so it doesn't have any other output that he wanted to add. So here is for the first part. So we did a backup, and we closed the channel with bad databases, in the sense that with revocated transaction, the node L1 tried to cheat the node L2, and the node L2 send its penalty transaction. Let's just quickly have a look at that test. So I just show you one because it's fun, two because this is really cool, and three maybe because I really love the test in the project, and more they have, more I like it, because you really see how the system works and how the API are meant to be used, where are the edge cases and everything. So it's really interesting. So this one has, if I'm not wrong, 70 lines, and we can see it's really something that we did here. They just open a double funded channel between L1 and L2, and at the node L1 spend a bit to the node L2, the node L2 spend again to the node L1, but before spending, the node L2 do a backup of the channel of the database that benefits him, as we did, and then close the channel, and the node L1 catch it. So this is everything that happened here. It's in Python, and maybe we can go. So here there are the options of the node. in that line that the node factory gets nodes, so it produces the topology on the two nodes, L1 and L2. Here we have the amount. We found the wallet with the same amount of sats. Here, this is the part where we do the double funding of the channel. So there's 50,000, 500,000 in both sides of the channel, and you can see here this is really as if we were calling the RPC command at the command line. So let's go back. We mine 6 blocks to make it happen. Here we are waiting in the log to see channel D normal, so that means that the channel has been open. Here we have other. We are also waiting for the channel to appear when we list them. And here the other path. So maybe I'm too fast, I don't know. Here, this is what we, the node L2 make an invoice of 10,000, and the node L1 pay that invoice. We generate some block, and now this is where the thing happened. So make database snapshot of L2, because after the node L2 is going to spend some coins, so this part will make this database here will benefit to him. So if we can see, so here we have the path of the database, this one that is exactly lightning that the one that we have. Here this is the backup, the same way we call it the same. Here we copy the file, so this is exactly what we did. And now we restart the node L2. Okay, so we restart the node L2. Great. We synchronize. Here we reconnect, and you can see this is exactly the command connect. And here info is for get info if you do it at the command line, and we get the ID. What can we see now? So now the node L2 spend some coins. So an invoice from the node L1 and the node L2 pay that invoice. Here we stop the two nodes. This is where there are kind of difference where we didn't stop the node that is being cheated in our case, but you can see there now we copy files, so we copy the backup to the original file, and we restart, and there this is where we closed with the wrong database. So this is where we are sending to the regtest chain the cheating transaction. We mine the block and we restart the node L1, and by seeing here in the log broadcast or penalty transaction, this is in some kinds that what we were looking at in the attribute status of list peers command. We see that the node L1 have seen the try to cheat of the node L2, and here we are done. Okay, so this is it for today. I hope you enjoy the video, and in other episode we are going to look at the tests, because they are really cool, really interesting, and many things to learn in those tests. And I hope you enjoy the ride in the first test that we see in the Ellen room. So see you in the next episode. Have a great time, and that's it.